When do groups perform better than individuals? Steiner's model says we should consider three factors. First, the group's resources, including human capital, money, time, information, equipment, and technology. Ask yourself questions like, do the members have access to the resources they need to do the work? Are the resources static or dynamic? Do they use these resources effectively and efficiently? If groups have access to the necessary resources and use them well, they tend to outperform individuals. Second, Steiner highlighted the effects of group processes like social loafing, group polarization, groupthink, and bias sampling. If not properly managed, these challenges can derail a group's performance. Other processes, like social facilitation and brainstorming, can boost a group's performance. Third, it's important to consider the task demands, or the characteristics that dictate how it should be completed. This includes its divisibility. Unitary tasks cannot be divided. They're simple enough that they can be completed by one person. But divisible tasks can be broken down into subtasks that can then be assigned to individuals. We should also consider the desired outcomes. Maximizing tasks make quantity a priority, while optimizing tasks focus on quality. Finally, we should consider how members contribute to the task. There are 5 categories shown here in this table. Additive tasks are completed by adding together members' input. These tasks are divisible and maximizing, and everyone performs the same job. For example, a group of students has to make a presentation. Each member makes one slide, and the slides are added together to complete the deck. Other examples include running a relay race and brainstorming new ideas. Here, groups typically outperform individuals, including the most productive member. Compensatory tasks are completed by averaging the members' input. For example, a team decides how much a project will cost by averaging the 6 group members' estimates. When the task is relatively easy, groups outperform individuals. That is, the wisdom of the crowd is often more accurate than the judgment of a single person. One reason for this is the averaging of judgments helps to eliminate outliers. However, when the task is relatively challenging and the situation is more ambiguous, individuals tend to outperform groups. This is because individuals have access to the same information as the group, but they aren't influenced by others. Groups complete disjunctive tasks by discussing the options and choosing the single best response. So, its performance is determined by the individual with the best performance. These tasks are unitary and optimizing. They can't be broken down into subtasks, and they require a correct answer. Think of a trivia night. Groups answer questions by selecting the response of the most knowledgeable or confident member. Here, groups outperform individuals because groups have access to a larger pool of information. However, individuals can outperform groups if the group doesn't recognize which member has the required knowledge, or if the group doesn't accept their input. Conjunctive tasks can only be completed when every member makes their contribution. If someone doesn't do their part, the group can't finish the task. So, its performance is determined by the person with the lowest performance. Conjunctive tasks require a high level of interdependence. Consider what happens when a relay runner drops the baton or doesn't finish the race. The entire team is disqualified. If this task is unitary, groups perform at the level of the worst performing member. But if this task is divided into subtasks that are assigned to members based on their skills and interests, groups perform better than the worst performing member. With discretionary tasks, groups decide how to combine members' input. For example, juries decide how they will determine the outcome of a case, or a project team uses the majority rules approach to decide which solution will be implemented. Group performance on these tasks is harder to predict, as it depends on many dynamic factors.